We're asked to solve this equation, and I'd like you to know two methods. The first method depends on the numbers working out nicely. The second method doesn't depend on that at all. It works for almost everything. You really do need to know both methods. On an exam, if I give you a problem where the numbers work out, you can use either method. If I give you a problem that has ugly numbers, then you've got to use the second method. You must know both methods. So the first method of solving an exponential equation is to try to make the bases on both sides match. So the question is, 16 equals 2 to what power? And the answer is 16 is 2 to the 4th power. Now once you have an equation where the base is the same on each side, then you can set the exponents equal to each other, solve, and check the answer by putting in, substituting in the x value into the original problem. So the question is, if you do that, if you substitute in the -1 in the original problem, do you get a true statement? Is 2 to the 4th 16? And the answer is yes, it checks. And so x equals -1 is the solution. This method depends on there being a common base, and that doesn't happen very often. So here's the second method. It's a little trickier. It uses logarithms, but it works even if this 16 was a 15 or a 14 or a 13, and you need to know this. And that is that since logarithms in a sense undo exponents, you can take the logarithm of both sides, and I'm going to use ln, the natural log. I could use the log base 10 if I wanted to. And now here we have the logarithm of a base to a power, and we know we can rewrite that by bringing out the power, the exponent, and multiplying that by the logarithm of the base. That's our power rule for exponents. And now we're trying to get x by itself, so we can divide both sides by the natural log of 2. And we have x plus 5 equals the natural log of 16 divided by the natural log of 2. We subtract both 5 from both sides, and we get x equals the natural log of 16 divided by the natural log of 2 minus 5. If you grab a calculator and do the work, you will find that this is 4, and 4 take away 5 is -1, and you're done. You need to know both methods so that when you want to, you can use this, which is sometimes slightly easier and faster, and then if that's not working for you, you can use this more powerful method that uses the idea of taking the natural log of both sides. One way to try to solve this equation is rewrite this logarithmic equation into an exponential equation. This is the base. The entire logarithm is the exponent, and the entire logarithm equals -2. And then this is supposed to be the result. And so the question is, can we solve this? Well, this equation, written this way, has x by itself. So yeah, we can do this. It's not too hard. It's 1 on top of 4 to the positive 2. It's 1/16. So the solution here is 1/16. And to solve this equation, it's a good idea to turn it into an exponential equation and look at it. So we have a base of 2 raised to this exponent. Remember, a logarithm is an exponent, equals this result. But 2 to the 5th power, that's 4 times 8. That's 32 equals 8 minus 6x. So subtracting 8 from both sides, 24 equals -6x. Dividing both sides by -6. We have x equals -4. Let's do a quick check of that. This is what's supposed to be true. Let's see if it makes any sense. That's 24 plus 8 being 32. So does 2 to the 5th power equal 32? Yes, it does. It checks. So x equals -4 is our answer. Here we're going to try to get the log base 5 of something on the right-hand side and the log base 5 of something on the left-hand side. On the right-hand side, we already have it. It's 20. Over here, we have the sum of two base 5 logarithms, and so we know that that can be written as the product. The logarithm base 5 of the product. That was our product rule for logarithms. And now, since both of these sides are exactly the same, the only differences are inside here, we can equate those two things. And that in essence makes the logarithms disappear, and we have a regular equation which is supposed to be a little easier to solve. Let's multiply this out. Notice the 4x and the -4x cancel. Let's add 16 to both sides. Let's take the square root of both sides, but when we do that, we need a plus or minus 6. So we're thinking that x equals 6 or x equals -6, but those need to be checked. So let's try them. Let's try the 6. Log base 5 of 6 plus 4, that's 10, plus the log base 5 of 6 minus 4, that's 2, is supposed to be able to be equal to the log base 5 of 20. But remember, the sum of two logarithms is the logarithm of the product. And 10 times 2 is 20, so that checks. So 6 works. -6 fails miserably because -6 produces negative numbers, and you can't take the logarithm of a negative number or 0. You can only take the logarithm of positive numbers. So the -6 does not lead anywhere. X equals 6 is our solution, and we're done.